Hello, thank you for checking out A1 Math. And today we're looking at simple and compound interest. Okay, now with the simple interest, there's a formula. There's a couple different formulas. I prefer this one. This is your amount is equal to your principal times your rate times your time, and then add your principal in again. Okay, so what we want to do is first find each one of those three parts there. The principal is going to be here with sure deposits $500. The rate, which is the interest rate at 3.75%, we're going to convert that into a decimal by moving it two places to the left. And the time is the number of years that we're going to have it in the bank. So in this case, it's 3 years. All right, so I have those three things, the principal, the rate, and the time. And I'm just going to put those in their proper value to find the amount here. All right, and notice that the P, the principal, we're going to put in twice. And everything else here is multiplied, but at the end, we're going to add back the principal. All right, and all you have to do is type this straight into your calculator, and your answer would be $556.25. And since we're dealing with money, you need to know to round up to the nearest whole number. Okay, now, um, so you would add that interest rate every single year, and that interest rate would be off your principal, the original principal. That's simple interest. With compound interest, you get a different interest added on each year or each time it compounds, and that's going to be your interest on top of your interest. So the formula is different. So let's take a look at a compound interest problem. So here we have $500 at 3.25%, but it's compound. So here you still need those three elements, the principal, the rate, and the time. But we're going to plug it in with a different formula here because we're going to raise it up to the amount of time that we are trying to calculate here. So I 5 by 3 values here. The principal, 500. I take my interest rate, convert it to decimal, 0.0325, and multiply it times 2 times for the years. I plug that in, and I'll have 500 times 1 plus 0.0325 raised to the second. And if you have a graphic calculator, it's real simple. You just type that in. If you do not, you will make sure you work the parentheses first, raise it to the exponent, and then multiply it times your 500. And once you do so, you will get $533.03. And that's compound interest. And remember, with compound interest, you're getting the interest on top of the interest. Okay. Now, in this example, we're dealing with the compound interest formula, but we're working with population. So the formula is the same. Um, and in this particular example, we don't have the time. We want to create a function where we could plug in how many years has passed and then figure out the estimated population. Okay. So in Blueville has a population of 7,000, and its population is increasing at a rate of 1.4%. So since it's increasing in our compound interest formula, you want to use plus. Okay. And just to create a function, all you would need to do is take the 1 plus your rate, in this case 0.014, and add the two together, and that's it. So we have 700 times 1.014 raised to the t. So we could plug in whatever year in for t and figure out the estimated population increase. Now in Greenville, the population is decreasing. It starts off with 8,000, it's going down by 1.75%. So instead of using addition, we'll use subtraction in our formula. And we'll make sure we'll do 1 minus that interest rate. And that's how we get our answer of 0.9825 raised to the t. So we can plug in how many years we want and figure out how much it's decreased in the population of Greenfield. Okay. Now, thank you for checking out A1 Math. That's looking at simple and compound interest and converting compound interest into a function notation. Um, thank you and have a nice day.